Hi, this is Randal Schwartz, host of FLOSS Weekly. This week, Aaron Newcomb joins me. We're going to be talking about virtualization with Xen. We've had them on 10 years ago, and they're back. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
This is FLOSS Weekly with Randal Schwartz and Aaron Newcomb, episode 515, recorded January 30, 2019, Xen Update. This episode of FLOSS Weekly is brought to you by DigitalOcean, the easiest cloud platform to deploy, manage, and scale applications. Over 150,000 businesses rely on DigitalOcean to remove infrastructure friction and deliver industry-leading price performance. Sign up today and receive a free $100 credit at do.co/twit. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randal Schwartz. MerlinAtStunners.com, bringing you each week, well, almost each week, the movers, the shakers, the big projects, little projects you may be using every day and not aware of it, projects you might want to download right after the show and play with. Today is probably one of those. Joining me once again is my lovely and talented co-host, Aaron Newcomb. Aaron, welcome back to the show.
Yeah, I'll take talented. I don't know about lovely.
All right. Well, you know, that's the usual sort of phrase we throw at the co-host these days. And where are you speaking to us from? It looks a little different than what we normally see you in.
Yeah, so I'm in the App Dynamics offices, and for whatever reason, the light in here is not conducive. But the audio, actually, if I had a nice mic, this room is padded. It's not a padded cell. It's a padded room for audio. So actually, if I could get the mics working in here, the audio sound quality is really good. So, I'm at work taking advantage of the audio facilities we have here.
Cool. And I am in the Tijuana kitchen set, as I like to call it, with all the wonderful refrigerator magnets behind me to my left. And I am on a hardwired connection, similar to a couple weeks ago, but this time not with the infinite bandwidth, but just 100 up, 100 down and 10 up, which isn't too bad. So it's good enough for a video show. So that's kind of nice. And I'm down here.
Did you say a hardware connection or a hardwired?
Hardwired connection. As opposed to a hardware connection. No, we have no hardware connections here. And I don't imagine there'll be too much gun shots or anything outside today. Actually, we haven't had that in a while here. So it's actually, it's relatively quiet. Tijuana is not as dangerous as most people would say. You just got to stay away from the really, really bad parts. That's all. So this week, we have another show. We have a great show today. First, I want to talk about last week. So last week, we did have a show lined up. The guests failed to respond to my final confirmation letter, so we had to cancel at the last minute, and I apologize for that. We'll try to get back on sometime in the future, but not happening today. So not happening this week, not happening last week. We'll talk a little bit more about that at the end of the show, but anyway, so sorry for not having a show last week. If you're expecting a FLOSS Weekly every week, we try to have it every week, but sometimes it just doesn't happen. So today is actually sort of a repeat show, a revisit show. We had Xen, the Xen Project, on around 10 years ago, I'm thinking. Let's see, I have my notes here somewhere. In 2009. So that was a long time ago. That was episode 67. So if you want to pause your listening right now and go back to the 2009 show, episode 67, you'll find out some stuff that we're not going to talk about today because we're going to talk about where it's gone since then and all that sort of stuff. It's also interesting. I listened to it a couple nights ago. And it's interesting in that it was back when Leo Laporte was the host of the show, and I was merely the co-host talking about things. And I ended up doing most of the interview last time, so I'll turn some of that over to you, Aaron, this time, of course. Because what is Xen? Xen is a hypervisor. It's a way of allowing multiple operating systems running at the same time on the same hardware. You might think of this as, say, the core of, say, what AWS uses, Amazon Web Services EC2, where you look like you own the entire machine, but really you're sharing that machine with dozens of other customers at the time. And it's really, really cool. And it's been in development for like 15 years now. So it's one of the oldest and probably the most important hypervisor project out there. Aaron, what do you know about this so far?
Yeah, so I think it's one of those projects that we all use and we don't realize it on a daily basis, right? It's running in the background. It's powering all these things. 10 years ago, it was new technology. We were talking about hypervisors and virtualization. And it was all brand new. And in the past 10 years, there's been, of course, the cloud has emerged, as it were. And you don't hear as much, at least I don't hear as much about Xen these days directly. But what you don't know is that it's in the background powering all of the instances, and of course, on top of those, the applications that people use on a daily basis. So I'm kind of curious to see. I think it'll be really good for us to discover how Xen has progressed in in those 10 years, but also like how it's being used today. What is it powering? How does it? How are we interacting with it behind the scenes?
Yeah, I don't even think we called it the cloud back then. I mean, there's before,
right.
Back then when we drew a cloud, it was represented the internet. So every diagram you drew of all your architecture always had to have a cloud somewhere, because that represented the outside world. But now cloud can represent not only the outside world, but also like sort of the inside world these days. So the cloud has become much more significant.
Yeah, that's right. And things like, especially when you start talking about doing things like private cloud, right? So things like OpenStack and Rackspace and all of those things that have been around for a while that people bring in, and they're like, I don't know if I want to go to Amazon AWS or Microsoft Azure, but I need something in-house that I can stand up that is cloudy. That'll enable me to develop my applications faster and provide services to people without having to worry about infrastructure, blah, blah, blah. We could go on. But yeah, I mean, these types of technologies really have become almost a standard, especially for large enterprises.
Cool, and we'll bring Lars Kurth on in a moment. He's the community coordinator, community manager for the Xen Project at this point. But before we do that, I do have a very important message, because this episode of FLOSS Weekly is brought to you by DigitalOcean. DigitalOcean provides the easiest cloud platform to deploy, manage, and scale applications with Droplets, virtual machines that are a scalable compute platform with add-on storage, security, and monitoring capabilities. You can choose from the standard or CPU-optimized Droplets and customize from there. DigitalOcean is designed for developers. The easy-to-use control panel and API lets developers spend more time coding and less time managing their infrastructure. Industry-leading price to performance. Access the compute resources you need at the lowest rates, saving up to 55% compared to other cloud providers. And you'll always know what you'll pay per month with a flat pricing structure across all data center regions. Included at no additional cost, 99.99% uptime SLA, cloud firewalls, monitoring and alerting, full DNS management, global data centers, enterprise SSDs, and an easy-to-use API. Over 150,000 businesses, including some of the world's fastest-growing startups, and including Stonehenge.com, my company, rely on DigitalOcean to remove infrastructure friction and deliver industry-leading price performance. Sign up today and receive a free $100 credit at do.co/twit. That's do.co/TWIT for a free $100 credit. And we thank DigitalOcean for their support of FLOSS Weekly. Let's go ahead and bring on Lars. Lars, welcome to the show.
Hey.
So tell us about Xen. What's the 30,000-foot view? What problem are you solving when you're reaching for Xen?
Well, as you pointed out beforehand, it's all about virtualization to a large degree, but not only. We also have a number of projects within the Xen Project around Xen, and sometimes also incubation of new ideas. So, for example, we have the hypervisor sub-project, a project to deliver drivers for Windows. We do have a project which looks at embedded and automotive applications as well, and a number of unikernel-related projects, such as MirageOS, which is a unikernel which came out of Cambridge University, and a relatively new project called Unicraft, which is basically an SDK to create custom unikernels for different runtime environments, for Xen, containers, native OSs, and at some point also bare metal.
So basically, it's like I described in the top of the show, right? Which is that it's a way of allowing an operating system to think it actually owns all of the hardware, when in fact it doesn't actually do that. Isn't that a great expense to be able to do that?
No, not today. There was quite a bit of overhead in the early days, but today most CPUs have acceleration, and so the cost is pretty much, it's primarily in terms of memory and disk footprint, because you have additional operating systems running in each VM, but you would have that anyway if you ran on additional machines. So at the end of the day, you trade off a bit of performance for and have less energy costs, space in data centers, all those kind of things. And similar dynamics also play out in other market segments, such as embedded and automotive.
You keep mentioning automotive, but I can't imagine I'd be wanting to run multiple operating systems on my car audio system, right? What are you mentioning automotive for? What is that about?
Well, this is kind of really interesting, and it also surprised me how this happened, because when I came into the Xen community around 2011, at that time there were attempts to bring Xen to laptops as well as mobiles. On the laptop front, we have operating systems such as CubeOS, which are built on top of Xen. It's a very security-focused open source project, but the momentum around cars happened only 3-4 years ago. We basically were at a developer summit. It was Global Logic at the time. They just, submitted a talk with this amazing demo where they were really showing the infotainment side running in one VM and basically some car functionality, such as like the little camera which you have at the back to park and things like that in other VMs. And then, of course, if you look at a car today, a high-end car has about 750 CPUs in it, so you can see where the whole consolidation play comes in.
Wait, a modern car has 750 CPUs? Are you talking really?
Yeah, well, microcontrollers, right? So right. They're technically CPUs, right?
Right.
Yeah, I was surprised about that as well, and and then when you talk to some of those guys, they start to have interesting challenges, right? Because a lot of the stuff is distributed over the car. I mean, some of it is centralized, but if something goes wrong, then you might have a piece of electronics somewhere which isn't easily accessible, and so on and so forth. So, I was really surprised about that whole, how this is happening, and but it's kind of cool, and it's also forcing me and other members of the community to address new challenges and problems.
So part of this, I presume, is for security reasons, because I've heard actually now of people who are breaking in through the infotainment system and actually accessing things like the brakes and the acceleration and things like that. Is Xen going to be able to help separate those so that even if you broke into the infotainment system, you're not getting access to more critical functions?
In some cases, but I think the bottom line is that the sort of isolation which a hypervisor like Xen provides is equivalent to having separate CPUs. So if you actually have an attack vector which comes through some network interface, in Xen you can isolate that in something called a driver domain, which is a specific VM where you just have drivers running in it. And so it helps. But, obviously, there's still attack routes, even in the automotive area. But, I think where this is going to start is basically, if I look at some of the examples which our community members are building. So there's one company called EPAM. They have this really cool system. There's Xen at the bottom. They have automotive-grade Linux, for the UI. They have a separate sort of VM for the map and navigation application. Then they have a whole set of VMs where you can just download containers, which then also run in a VM. And that would be for things like, I don't know whether they have this in the US, but if you're like a beginner's driver or you have bad driving habits, normally your insurance premium goes up. And what you can do today to then get your premiums back down again is you have a little box installed in your car which sends data back to the insurance. And if you're a good driver, then your premium eventually goes around, right? And then the idea there is that you could collaborate with a car vendor and then just and an insurance as an OEM. It's a little confusing, this whole terminology, because an OEM in the automotive industry is actually a car manufacturer. And which is quite different to what we're used to in the IT industry. And at the end of the day, if this is all set up in a cloud, you could just enable a switch, and then automatically a container with a certain application gets downloaded to the car, and then it's just like enabled out of the box. Or if you had a small taxi company, you could just download a little fleet management container app, and that'll track your cars and collect telemetric information and all sorts of stuff. So this is really quite interesting. There's a lot of possibilities.
So what's the advantage to that kind of a setup versus just simply running these as separate processes under Linux? Well, I mean, that comes back down to consolidation, because you have more chips, right? So that produces more heat. It's more complexity in hardware. So there's, the whole update process is potentially a lot more complex, because you would have to have an update mechanism for your software for each individual CPU, which, incidentally, they might also have different operating systems, on them. And that just becomes a lot more complex. And just generally, I think consolidating is quite a strong use case here. So I think it's really partly about cutting costs. It's also about energy consumption, because if the car's not driving, then of course you're running off the battery, right? And also, interestingly, when you talk to some of those guys, sometimes it can also be about heat production. Because if I mentioned this little camera for parking earlier, and I think I talked to one of the engineers who was working for a big car manufacturer. I'm not sure I can tell the name; they're all fairly secretive. And he said basically, they sometimes had problems where when that camera is used too much, it basically could create a heat problem and put the car, on fire and things like that. Things we don't really normally think about when we talk about electronics. But yeah, I was saying earlier, learning new things. So that's kind of what we as a community also have to do now, because this whole area is creating new and interesting challenges, problems. Well, I'm still not really convinced yet, though. Maybe I'm just misinterpreting something here, but I'm not really convinced that, having a Xen with a microkernel spreading it out over entirely separate operating systems running on sort of unaware of each other is going to be any less energy efficient, or any more energy efficient, I should say, than just simply running them as processes under a single kernel. Maybe am I misunderstanding something here?
No, I think the energy aspect is probably not the primary one. I think it's about it's a lot easier to develop against a virtual environment. Also, of course, there are already commercial hypervisors in some of the cars today. So there's a whole industry for embedded type of hypervisors today. And it seems to be, that there's no real open source solution today. And, as I said, this whole thing was surprising me. And, but, as a community guy, I'm really supporting this as much as I can. And there seems to be a lot of momentum in this area today.
Well, we're sort of deep into a tangent here. I want to get back to the basics here, just to kind of give people a better sense of what this is. So, how did the Xen Project get started, and what was its initial goal? And I know it was before the word cloud was actually starting to be used. So what happened to provide impetus to the initial relationship of Xen?
So Xen originally came out of Cambridge University. The project officially started in 2003 when Xensource, which was a startup at the time, was created to commercialize the research from Cambridge University. The research at the time I think it was called Project Xenos, and that all was, that was kind of like a bigger project which really looked at how you could create infrastructure which would allow what we today call the cloud. So 2003, was when the code was published. This was in October, so we just had our 15th birthday. I think another major milestone was around 2005 to 2006. This is when Intel and AMD added hardware virtualization support to the project, because what we had to do in the early days is come up with an approach to work around the limitations of hardware to basically create virtual environments and trick operating systems into believing that they were running on different CPUs, because that's basically primarily what virtualization is about. 2005 it was also interesting. I can't remember whether it was 2005 or 2006 now. That's when Amazon and Slicehost, which was later acquired by Rackspace, launched their first clouds, and that were basically the first official cloud providers in the world.
Yeah, and I don't want to go down too much of memory lane here, but I mean, I remember at the time it seems like there was a lot of back and forth between Xen and KVM. Is that still the case? Am I not remembering that correctly? But I mean, it seems like there was. I was working at Sun at the time, and it seems like it consolidated on Xen for virtualization, but it seems like there was basic KVM or kernel-based virtual machines that were somewhat competing. Do I remember that correctly?
I think this happened a little bit later. So basically, I should have really done my homework. I think KVM started to be developed around 2006. And of course, the two projects really compete with each other in some areas. Today, they're quite similar in some respects, but they're also different in others. So, for example, like if you look at your typical KVM environment, it's very focused around integration with Linux, whereas Xen, for example, is operating system agnostic, right?
Yeah.
And there's architectural differences and so on. And I suppose, in some areas, Xen is ahead, in others, KVM is. And, at the end of the day, competition is really good, because that prevents you from being complacent.
Yeah, but both implementations, both projects, and they're both open source projects, number one, and they're both out there today in the industry. It's not that one has dominated over the other, so to speak.
Yeah, I think that's a fair enough assessment today.
Yeah. And then the other thing I wanted to ask you is a lot of, when I talk about this with our customers, a lot of the ways I talk about cloud a lot, and a lot of the ways that that I kind of describe what's happened over the years is, we had these standalone servers in the data center, and then virtualization came about, and then we had servers with virtualized instances on them in the data center. And then you go to cloud and you have containers and serverless, right? So you got kind of go from tens of servers, let's say, to hundreds of VMs to, thousands, if not tens of thousands of containers and serverless functions running. I mean, in that kind of scope of things, is it accurate what I said at the beginning, where Xen and other virtualization mechanisms are still running in the background, even though you don't see them? You may think of running containers, and a lot of people do, but really virtualized systems are really kind of at the basis of the infrastructure of pretty much all clouds out there today.
I think that's entirely true, yes. I think there might be the one other service which only uses containers. I think, I'm not quite sure whether that's the case, but I think all the Google Docs and those kind of things, use containers underneath instead of VM instances. So I think if you talk about cloud providers, you're probably right. If you just generally, talk about services being delivered on cloud-like infrastructure, probably not in all cases.
Yeah. So we have virtualization kind of as the basis of cloud technologies, and then what about how much work that goes into? Because I know that there's a lot of virtualization technology that's built into CPUs themselves, right? From Intel, AMD, and others. How much work goes into making sure that correlating between you and the chip manufacturers to make sure that those features can be used by end users?
This is where the whole open source model comes in, because if I really look at it, primarily all those features are contributed by the CPU vendors. And sometimes, of course, obviously there's maintainers and committers and so on, which review other people's code. But, that's just a sort of standard way of working in open source. So, really the bottom line is those features, do primarily get implemented by the CPU vendors. And, if you look at the project structure, project is a Linux Foundation collaborative project. So we have a board and we have members which help fund community activities. And so you will see all the major CPU manufacturers on that board.
Oh, really? So they're on the committees and they're contributing code as well.
Yeah.
Wow. I guess that's a testament to the open source model. I mean, we talk about this a lot on the show, but having an open source project like this where you can actually get, third parties, major manufacturers in this case, to actually contribute code to your project is a huge win and speaks to the collaborative nature of open source, I think. Would you agree?
Yeah, totally. And it's also this actually happened from the early days. I was mentioning earlier that 2005 and 2006, Intel and AMD basically added the support to Xen to start using the first virtualization extensions which showed up in those chips at the time. So this was something, which at the time only Intel and AMD could do because they were basically working on this kind of stuff, presumably in secret. And then, then there was an announcement and patches landed. And I guess that's, in many ways, that's still how it is today. Yeah.
I remember using those extensions for the first time and running a virtual machine on my desktop and just being kind of blown away at the improvements that could be made, because there's a kind of a direct communication from the virtual machine right into the CPU at that point, and that was huge. Was there ever any discussion about closing this project out? Was it started as open source? Has it always been thought of as an open source project, or was there ever any attempts to either close it down or fork it off and make some closed projects from it?
Well, I'm not aware of any attempts to close it out. It started off as an open source project with a GPL license. At some point, Citrix acquired Xensource, and Citrix continued working in public with the project. And I started with the project around 2011, and I made the case to the Citrix management at the time, to actually put the project on a proper open source footing and to basically, move it into an open source foundation. And, at the end of the day, the Linux Foundation kind of was the best fit at the time. And so we did that. And, if I look at the project today, it's, pretty much everything's totally independently run, like a proper open source project.
That's great. Excuse me. You mentioned some other areas when we first started the discussion beyond just standard virtualization that you're working on. Can you kind of go over some of those other parts of or maybe they're independent projects? I don't know. How is that even structured?
Yeah. So basically we have a number of teams within the Xen project. Sometimes we call them sub-project, but calling having a Xen Project sub-project just sounds really weird. So we normally call them teams. Yeah. So we have a team that looks after Mirage OS. That's a unikernel. I think it's actually the first unikernel. That's another project which originally originated from Cambridge University. We have another sub-project or team which is really new. That is called Unicraft. It's sponsored by NEC, and it's basically an SDK to create unikernel bases. So if you look at a unikernel, it's kind of like
unikernel? I think a lot of our audience.
Yeah.
What is it?
I was just going to explain that, right? So at the end of the day, a unikernel is basically like It's kind of like a microservice which you can run pretty much everywhere. But the key differentiator to what you normally consider a microservice, which is implemented using containers, is the entire image, including the OS, is basically your application, right? So, and that creates some really interesting benefits. It also kind of makes it really hard to develop unikernel applications, right? Because you have no OS. You have this huge library, which might, integrate with your OS, or uses some services of it, but that's sort of kind of hidden. So if you look at really old applications, like old embedded applications, what you would use there is, you would also have like a library of your basic OS functions. You then, add your application, and then you have a ROM image coming out, right? So conceptually, it's kind of similar. But what that really means is you have to have all these different lower levels, which we tend to call a unikernel base, which provide basic operating system functionality in some way, shape, or another. And today, that isn't standardized. There's like loads of different unikernel projects out there. And what Unicraft does, it provides like a base, like an SDK to where you can pick and choose what you want. And then, you combine it with your app for the specific unikernel API, and then you have that image coming out. So it's actually a really cool project. It's quite difficult to explain, but does that make sense?
That's a good way to. Yeah, I think that's a great way to visualize it, actually. And I'm trying to imagine the implications of that. For performance, for instantiation, or startup time, and security. It seems like there may be some benefits there. Is this a better performing way to run microservices or applications, or is it slower as compared to running them in containers, for example?
Well, so I think basically the security benefits, because you have a lot less code, because a lot of it is taken out. You get definite size benefits as well, so your images will be smaller. So that means that they're actually interesting for embedded and IoT edge, and as well as cloud in many ways, because you can basically build an image for a specific runtime environment. It's also kind of portable. Also, how well this works in practice will remain to be seen. So there's still challenges in this area, and then startup latency is quite incredible. It just takes a few microseconds really to bring up, one of those unikernel VMs if you run it in a VM.
How is that possible? I mean, it seems like if you have more of the kernel and all of those things embedded, so to speak, in the unit. I don't want to call it a container. In this thing that we're calling the unikernel, I mean, if you have every kind of things embedded, it seems like it would take longer to spin up, but it actually spins up faster.
Oh, but you don't have an operating system which you need to boot, right? So if you imagine, basically, if you look at your typical VM, the hypervisor actually needs to provide the access such that you can set up networking and all this kind of stuff, right? And in some cases, and I think that works both in KVM and Xen, you kind of can bypass, you can just directly access that infrastructure if you set it up right. And so basically, as soon as the VM is created, that library code, which builds the base of your stack, just needs to be initialized. And that's kind of very fast operation. In some sense, that's kind of quite similar or maybe even faster to your tradition, to containers, because basically there you just have an operating system set of APIs passed through to each container, and the setup is basically done by the host OS, so it's conceptually sort of similar.
Right.
So I think if you compare unikernels to other microservices, I don't really know what the speed difference is. I think that depends very much on the application as well as on on your environment and so on and so forth. But it's probably quite similar. But if you compare it to a traditional VM, then obviously it's going to be a lot faster because you don't have to boot the operating system first.
Right. So that makes a lot of sense. Is that how this came about initially? It was somebody said, hey, these VMs are great, but the operating system's getting in the way. Can we kind of shortcut that path down and make it a lot quicker? Is that how this came? How did this even evolve, especially in light of the Xen project?
So I think that, like in many things in the Xen project, a lot of ideas come from university research and eventually become commercialized. So Cambridge University has been a center for research around library OSs, which is actually a very old concept, where you don't really have a separated operating system, but you just have a library and you link it into your application. And so that research, I can't remember, it's just been going on forever. And out of that group of research then came Mirage OS, which was one of the first unikernels. I think it was the first. And then later on, additional, unikernels. No, actually, it wasn't the first unikernel project. The first unikernel project is something called HalVM, which basically, your unikernel interface is a Haskell runtime, and you just put a Haskell application on top of it, and then the tools just build this image, which looks like a specific VM image, and you can just then deploy it on any cloud. And there's some interesting use. There's actually Galois, who is the company that happened to be based in Portland, who developed HalVM. They also have built an interesting security product with the technology. It's called CyberChaff. And basically what they do is, if you have a big corporate network, you get attacked by intruders all the time. So they've been working on the assumption, there's like a virtual infrastructure, and then they just created all these little, they call them honeypots, the tiny little VMs, which look like legitimate targets. And, because those little VM images are just 4 or 5, they're tiny, they're just a few hundred Ks, you can just easily deploy them around your network. And then, attackers just get distracted and might go for one of those honeypots rather than real services. And then you can track down where they came from.
Right. Yeah, I mean, this is used pretty widely now, actually, for security purposes.
Yeah, I think that's true.
Yeah. I wanted to bring up some other projects, and then I promise I'll let Randal jump back in because I know he's got some questions as well. But I enjoy talking about this stuff. It's kind of my bread and butter and the world that I live in usually on a daily basis. So there are other virtualization VMware obviously is probably the biggest. I would think anyway. Correct me if I'm wrong. The biggest commercial virtualization vendor, right, in the industry. And then you also have like I've used VirtualBox, for example, on the desktop, and then I've also used QEMU in the Linux command line. In fact, as part of my book, I mentioned a virtual Raspberry Pi instance that you can run to kind of get access to Virtual Pi. That's running virtualized in QEMU. You can download that and run it. It's using both VirtualBox and QEMU to make that happen, which is virtualizing and then virtualizing on top of that. It was kind of crazy virtualization inception going on there. Back to my question. How does Xen play with all these other systems, both for desktop virtualization? Like, have they found a niche, so to speak, with end users that Xen tends to be used by this type of person doing this type of workload, and then VMware tends to be used by this other thing?
Yeah, so I think so that's actually kind of an interesting story because about 10 years ago, there was an attempt to bring desktop virtualization, not in the VirtualBox sense where you have an application and you can virtualize applications, but in a sense that instead of having an operating system, you would install some sort of virtualization platform on your device, and then you can run multiple environments on that device. So there were multiple companies who were trying to bring this to market. I think Citrix was one of them. There was a company called NXTop and Neosphere, and so on. But that didn't really pick up. So, we do have solutions in the space which are quite successful. There's Qubes OS. So Qubes OS is basically a security-focused Linux distro. I think it's based on Fedora. It uses Xen underneath. And basically, you have different virtual machines where different parts of the operating system run in, and then the user interface aggregates everything into an experience such that it looks like a regular OS. There's also so that's kind of quite, it's a really cool thing, but it's fairly niche to people who care about security. Then we have something called Secure View, and that is basically used by military types. At the end of the day, that's what it was developed for. So I think, to just kind of close this, or, to summarize the discussion, as that's sort of constrained today to an audience which really security.
Cool. Well, we're almost out of time. It's just that the hour goes by really fast these days, and we get started a little late. So if you at home are looking at your watch going, it's not quite, the bottom of the hour yet, but or the top of the hour, whatever I guess it would be. But I did want to ask a couple questions. So would I use Xen on top of Mac OS, or is this something that really wants to own the entire CPU when it's running?
It wants to own the entire system when it's running, right? So if you install it on a Linux box, basically you install it instead of it's a little bit more subtle than that, but you basically can change your boot manager such that you have a Xen instance running, and then when it boots up, it first boots Xen, and then it gets changed via Grub or something like that, and then you automatically have the operating system coming up. But yeah, in a nutshell, it does take over the entire device. It has to be started first.
So let's flip the question then. Can I run Mac OS underneath Xen?
Technically, you can. I think in practice, I recall many years ago there was a demo of that, and then it turned out that there were legal issues which would prevent you from making this happen.
Oh, yes. Well, I know I'm firmly aware what the current restriction is, that you cannot run Mac OS on anything other than Mac hardware, Apple hardware, but you can run it inside a VM that is running on Apple hardware. So, for example, I could run a second instance of Mac OS, like maybe the next release or something, underneath, say, VMware or VirtualBox. So that's legal. And I'm not a lawyer, so don't write me and say, Randy, you got that wrong. But I think that's my understanding right now. Is that you have to actually have it on something like that. So how does Xen compare, say, to something like VirtualBox or VMware then? So because those could both run as sort of like applications underneath a native operating system. So why does Xen need to take over the hardware?
Oh, but I thought, some of the VMware products for server do that as well, right? So,
okay.
So we just, I think in the community, we just never really had enough momentum to basically end up with a project or a sub-project which would allow you to do that. I think there was an attempt at one point to do that. It was called Hosted Xen, to take the same code base and run a different configuration, but that never really picked off. I think it's technically feasible, but it's be quite a bit of work, taking a code base which is designed for a different purpose and then just modify it to fit that other goal. And there are now, of course, also established players out there, so it really doesn't make sense to try and do that.
And what's in the future for Xen? So and who decides that?
Well, there's we don't really have a single authority which decides the direction of the project. So at the end of the day, our community and the people who actually do stuff and upstream stuff decide where the project goes. If I look at the project, we have different constituencies. So we have the cloud and server virtualization providers. We have a whole group of security vendors and also military types who have products built on top of the project. And then we have this new emerging embedded and automotive segment. Now, if you look at virtualization in general, it's actually a fairly mature area of technology. So you wouldn't necessarily expect a lot of really cool, interesting new stuff, at least in established market segments. But what I'm seeing is that there's a lot of momentum around things like embedded and automotive, which have quite different requirements on top of what we have today, which is driving interesting innovation.
Cool. And you mentioned military. Is this something that's military hardened? I mean, does this have to have passed some particular security levels?
Yeah. So this is actually quite an interesting story. So there are a number of Xen forks, essentially, which are maintained by either by companies or presumably government agencies. I don't really quite know. And one of the things they have done is they basically, taking everything out they don't need and then certified, the rest of it. And it's basically like any other project, which the product which is built on top of an open source base, they just happen to be certified.
Cool. And like I said, we're almost out of time. Is there anything you haven't? Is there anything we haven't asked of you that you wanted to make sure our audience is aware of before we have to let you go?
Yeah, so we have our developer summit coming up in Chicago on July 9 to 11th. So if you're in that area, it might be interesting to sign up. The website's live already. And yeah, just follow our blog. And, you can also get in touch with me via our IC channel, that's XenDevel, and many other channels. That's really all. Thank you for giving me the time.
Cool. And also, I have two questions I have to ask you because my audience will actually email me in about 15 minutes if I don't. What's your favorite text editor?
Oh. I mostly just use text edit. Sometimes I use Y. I just use all of them. I'm used to all the Y shortcuts, or Vim. So I do like that one.
Yeah.
Good answer. Yeah. Aaron's happy. I'm not, because it's not Emacs, but that's okay. And I'm doing VS Code most of these days now to do stuff on for Dart and Flutter. So that's a good thing for me. I've finally gotten out of Emacs, believe it or not, which is a little scary. I'm still using Emacs most of the time though. And then your favorite scripting language.
I kind of like Perl, even so, it had a bad reputation.
Yay!
That doesn't happen very often.
That doesn't happen very often.
Maybe we're the same age group. I don't know.
I think we probably are. I think we started back in the early days of computing and have the days before the internet. I think is probably what you're trying to talk about. Yeah, Perl was big to help create the internet as well. But that's enough of that. Okay, well, we're out of time, so I want to thank you once again to come on the show, Lars Kurth. Welcome and not welcome. Goodbye, and thanks for talking about Xen. Bye, Lars.
Thank you. Bye.
Okay, that was Lars Kurth talking about Xen. What do you think there, Aaron?
Well, it's really interesting. I mentioned this at the beginning. You just don't think about Xen as much as you used to. It's one of those things that's running in the background. It's driving all these cool things, and it's you just don't realize that it's there. But all of these improvements and innovations and input from the community and input from industry has been happening and continues to happen for this project that, like you said, we first talked about 10 years ago. Crazy to think, right? Mm-hmm. But it's going on. And so I think that it's one of those important projects. I'm really glad that we had the chance to have them back on the show to talk about what's been going on over the years.
And it was cloud before cloud was cool. And I like how the design of Xen helped improve the hardware virtualization aspects so that AMD and Intel had to jump into the project to say, we need better ways to be able to do things like virtual Ethernet and virtual memory management that weren't around back then. They had to do it the hard way back when they were first creating Xen. So I'm glad that that's all changed, because I tell you, if you're on the internet today, if you're not going to be a Luddite all day, if you're actually going to be on the internet today and you hit a website, I bet you 80% of the time that's on a machine that's running Xen to provide that service for you. I'm just guessing at the number 80%. It could be just pulled out of my tail, but whatever. Anyway, because it's that important. It's that important to be able to have all this hardware that's deployed out there and shared in such a way that, when this particular website needs more CPU, it can get it, and this website doesn't need as much, it can get that. And very, very, very important. Anything else before we wrap up here?
No. I was just going to say, I don't think it's overreaching to say that virtualization in general is one of those huge milestones for the computer industry, right? I mean, you think about all these things that happened, and Unix is one of them, and virtualized file systems is another one, and all of these things. But virtualization, server virtualization, is one of the huge milestones in our industry. So it can't be understated, its importance in getting where we're at today.
Absolutely. Okay, so our upcoming guests are very short right now. I'm going to start sending out some email this weekend, I guess, to get that filled back out. Next week, we will have open source and Instacluster. They are apparently a big contributor to the Kafka and Cassandra frameworks. And then Ion. For those of you that are waiting for the next blockchain show, it's coming up. At the root of the Ion network is a purpose-built public blockchain called Ion One. Designed to connect other blockchains and manage its own robust applications, Ion One also provides the economic system that incentivizes interoperability in the ecosystem. And that's going to be a buzzword bingo show for sure. If you go to twit.tv/floss, that's the homepage for this show. You'll see all of our upcoming guests, which aren't very many at the moment, but we'll have the people I've actually been emailing and contacting. If you have any other suggestions, please tell me. Please tell the project leader or the community coordinator to email me. That's how a lot of these recent shows got on, especially if it's not cryptocurrency cryptocurrency or something like that. We have a live stream at 9:30 a.m. Pacific time on Wednesdays at live.twit.tv. You can follow us at Floss Weekly on Google Plus or at Floss Weekly on Twitter. You can follow me at Randal L. Schwartz on Google Plus for at least a few months more until they cut that off, and at Merlin on Twitter. And we'll figure out some other place I'll be posting, probably on Medium. I kind of like Medium as a medium. It's actually pretty nicely to read stories there and have keywords and things like that. So I'll probably be actually promoting over there from time on. I'm going to be up in March, early March, which is just coming around the corner. I'm going to be at Scale 2019 in Pasadena. So if you're going to Pasadena, please stop by and say hi. I will be hosting a Birds of a Feather talk on Flutter and Dart, but I don't have any actual talks I'm deliberating. I'm doing something like that. I use English, Randall. Anyway, and I don't have anything else sort of in the near term just yet. I'm looking at going to be at a show in Philadelphia, I think, coming up soon. But other than that, I'll talk about those next week, I guess, because I don't have them written down here. So anything you want to plug, Aaron?
Yeah, so I'll be down at SaaStr in San Jose. SaaStr is a conference for SaaS-based software. So if you happen to be down at SaaStr, I wouldn't imagine there'd be a lot of people on this. But if you're watching and you're going to be at SaaStr, let me know. I'd love to hook up, get a beer or a drink or something, or just meet you and talk to you. So let me know if you're going to be doing that. Also, there's always this book here, which I happen to have a copy of today, Linux for Makers. There it is. Ta-da! You can go out and buy that book on Amazon or anywhere else. Where they sell it. It's all over the place. Keep your eyes out for Humble Bundles, which happen if you just want to grab it digitally. Occasionally there'll be a Humble Bundle with Linux for Makers included in it. You can get it and just peruse it via an e-reader or something like that. So go out and check out that book. It'll help you understand how Linux works and operates on single board computers like Raspberry Pi. Other than that, you can also check out VenetiaMakerspace.org. Venetia Makerspace is the local makerspace I run here in Northern California. So if you're interested or know someone that's looking for a makerspace around here, please point them in our direction. I think that's about it.
And Aaron, thank you once again for helping me produce the show today. And hopefully next time when you come to that wonderful conference room that has the padded walls, you'll actually have a microphone in there instead of having to use your earbuds.
I've got the microphone, right? I mean, I've got it right here. It's just I couldn't get it hooked up today. I've got two other really nice microphones, but I'm going to talk to them about getting some lighting, getting the mics working, all that kind of stuff, because we should they use it for recording. They don't necessarily use it for streaming.
I see. Yeah, that's probably a big difference there. Anyway, so again, thank you, Aaron, and we'll see you all again next week, hopefully, on Floss Weekly.